So good afternoon, everyone, and welcome to the penultimate event in Cita's Tech Trends Series 2022. This afternoon, we're going to be looking at automation and robotic futures. My name is Alan Hoare, based in TU Dublin, in the School of Surveying and Construction Innovation. And I'm also one of the founders of the Construction IT Alliance. So just before we commence the event, I want to just thank our sponsors, Arup and Diatech, Celebri, who are part of the Symmetry Group, Linesight, Fifth Dimension, and also the continued support of Cita SkillNet. So we can go to the next slide, please. I'd like to just, I suppose, introduce the Alliance. It's a not-for-profit organization, and we run a series of events. So this is our Tech Trend series, but we also run a digital housing series. We're involved in the Build Digital project in Ireland, which is funded by DEEPR. And we also have a regional week series as well. And indeed, early this year, we had our Tech Live event. And next year, we're looking forward to the Cita BIM gathering. So we're delighted that we have a number of very knowledgeable speakers with us this afternoon. I'd like to welcome JJ O'Hara from FutureCast,
Thank you.
Nicholas Syed and Simon Clavlin from Arup, and also Matthew Bester from Leica Geosystems. So you're all very welcome. So when it comes to, I suppose, AI in construction, would it be fair to say that the construction industry is perhaps a late adopter of AI and robotics? Some might say that even these technologies are somewhat hyped. But I think this topic area will become more and more persuasive in the medium to long-term future, particularly the potential of automation and robotics to deal with the perennial problem of productivity, compliance checking, and ensuring quality of construction, and above all, to ensure that our sites are safer to work on. We understand that there are ethical issues around collecting data, but any of you that are perhaps considering starting a digital journey, this is certainly one topic that we would recommend you look at. So I'm going to hand over now to our first speaker. JJ, you're very welcome.
Thank you very much. How are you all? My name is JJ O'Hara from FutureCast. So we're an innovation center for the quarry and construction industry. So this is just where our center is based in Marahampton, County Leitrim, and we also have a facility in Drogheda working closely with Hardcore Technologies. So next slide there. Yeah, so FutureCast work with construction and quarry companies throughout Ireland, the construction supply chain and construction machinery. We look at sustainability, green, robotic and technologies. So next slide there. So look at it, our main thing is looking at modern methods of construction and what way that'll happen and how will it happen over the next 5 to 10 years. We're saying, look at 13% will be roughly 3D printing. We say over 50% will be made in factories, and what robotic and automation processes will happen. This is a very interesting, and it is happening already with some of the factories that's going up. And it is, to create quality and what that quality will be, So it's looking outside the box and where it is. Next slide. So we brought in the first 3D printer into Ireland. We have a base there in Drogheda. We're doing education with about 120 people already put through education on it. One-day courses. Now we're starting a 2-day series, and we'll have a 6-week series later coming on in 2023. So like we printed one story, 2.7 in less than 6 hours there 2 weeks ago. What we're doing is creating it's very similar to the construction, cavity wall construction it is already, and just developing that, so we've got it through London Building Control, now it's gone through, it's in an NSAI standard at the moment. It's there for anyone to look at up to the 5th of December and to evaluate on that. Next slide. So look at, the reality to in factory and module homes is going to be very, very much coming into play. And like it's about the robotic and automation process and that. This is a thing called Mega to build module houses. It's 60 robots. It's developed by KUKA, ABP is developing, FANUC is developing different systems. It's really going on the car industry and what the car industry were before. We're in a place in Ballyjames-Duff there on Tuesday night with CIF and looking at the different developments in this. And same with other companies like Vision and Tuppercurry or High Term Homes and Leash. So these really come to the forefront, what module construction. So like a 3-bedroom house made in a factory, 4 different modules and put straight onto site. So there's good examples of this right across the world, and this is where we see it going. As the quality element that can be within the robotic process within this. Look at some of these modules have the bathrooms already in, kitchens already in, and it's just coming straight to site with Larry. This is where we see probably 50% of houses actually developing in the next 5 to 10 years. Next slide. So look at other projects that we're working on. Robotics is coming very, very much into the industry. Like, up the top left there is a robotic block laying system in Australia that we're looking at. There's on the right there is robotic in our quarry. It's a robotic block laying machine that has been there in the quarry the last 10 years. Robotics is nothing new, but it is becoming more prevalent. And, I think it is a mixture where we see it is coming mixing digitization, robotics, and with trades. If you on the right down the bottom, there's a robotic bagging plant that we're putting into a quarry. With this system, like it'll be 5 pallets coming out every 40 minutes, but with a full VR and an AR system on the machines and a digital twin back to our innovation center as well. Robotic welding as well is coming very much into the steel operation. Like, there's some very good companies designing some brilliant stuff. Pro Design down in Limerick, some of the very interesting for steel development within high rise and construction buildings as well. Next slide there. What we see on the top left-hand corner here, or right, what our team is looking at is about innovation, development, and the research and the education that we can provide, at each of these. So what we developed is some of the machines here, look at the design, what is the texture, what is the hydraulics, what is the, metronics that each of these machines is working with. Same with autonomous vehicles, like we're talking to Volvo there. Autonomous vehicles is very much come to the forefront, especially within the quarry industry. The concrete plant doesn't move. The crusher is most likely doesn't move only once a month every year. And it's about A to B and where autonomous vehicles can come in a very safe environment. You see CAT there last month, they were running a dozer 5,000 miles away. There's perfect examples of what's happening at the moment within the industry. Next slide. Same with, robotics, robotic dog there from Boston Dynamics and Leica scanner, which you'll hear more about. This is coming very prevalent as about for surveying and about quantities, The right there is a robotic bricklaying machine. It's about, what can the new quantities, what is the new technology that is come to the forefront to calculate what's been built on a daily or weekly building process, like within a major sites. So technology is coming very much to the forefront. We've seen this down in Tara Mines, and it's about, what is the next steps in each of these technologies. Next step. Next slide. So look at what we're saying, like there's 30 to 40 different new jobs coming into the industry. And it's about, adapting our young people to look at these new jobs right across the quarry, construction, and the manufacturing supply chain that we see. But it's also, the person that is leaving the industry. In construction industry, we lose a lot of our talented staff at 40 years of age. And our thought process here is them talented staff can be retrained digitization to go into some of the factories to look at the robotic process, to work on the 3D printers. And it's about thinking outside the box, because we lose major of our talent because block layers, plasters, it is, to get tired or bone structure or whatever, and they leave it to go to different jobs. We lose that knowledge of our industry. our thought process here that we retrain them and get them back into get another 10 or 15 years out. Next slide. So look at, there's definitely different advancements going on in what we see and what courses that we're developing, like artificial intelligence in a quarry, blockchain. We're doing blockchain in health and safety in a quarry, in a construction site, in a manufacturing. We have first course coming out this year on blockchain, an introduction to blockchain on a manufacturing site. So look at, I think there's a lot of new advancements and new courses coming out, and see with our own SkillNet Industry 4 SkillNet and with Cita, and it's about working together and coming together and saying, look at what is the industry of the future look like. We see the robotic processes within this construction coming very fast down the line. Next slide. So that's it from me, FutureCast there. Look at contact us there, futurecast.info. Contacts through Cita or Industry 4 SkillNet, and I think it's about us all working together to look at where the future is. Thank you very much.
Thanks, JJ. Just before we go on to our next speaker, I might just ask one or two questions, and then we have a question coming from the audience, if that's okay. You spoke at the very start about automated automation in off-site construction. And you made quite a bold statement when you mentioned between 50 and 70% of these homes will be built by robots. Is that right?
What we said is, yeah, what I said is 50% will be built within factory settings.
Okay.
I think that's a very valid, but it was what the process that you put in it. Like the system called Mega, there can be it can be a cold rolled steel, it can be a timber frame panel, or it can be concrete panel. It doesn't matter what the start or the finish, but it is the automation process that is in between. And the same with ABP or the same with FANUC. They're developing different systems.
And of course, the big advantage of single task robots, for example, would be that the repeatability of it and the fact that you're getting that consistency of construction, I suppose. Yeah.
And that's a big factor, because some of our architects were working with looking at 16 different designs within social housing, and what can each of them panels to work within for each of the designs. But it is that repetition that it can go into a robotic process then. Like robotics is great, it is a repetitive thing that you need to have them in, and it is a line, but it has been done for years in the car industry. What we're saying is look at your module houses, look at the system that you can run on a line. Take the construction factor out, look at the manufacturing that could actually produce houses. Like we see BAM there and different companies, CISC, and what they're doing at present. Like some of them are putting out 2 houses a week. Some of the Ukrainian modules, they'll be putting out 10 modules a week. So these is real facts that is coming to industry. But not only that, I think there's a huge export market here. My background would be from US working. And, I think Ireland could actually lead out in this to create a huge export market in module development to export out.
Yeah, absolutely. We have a question there from Robin Evans. Good afternoon. How does BIM tie in with the modular robotic driven construction methodologies you've used so far? I've heard of issues with projects using CNC for laminated timber, where the current design software cannot export the needed quality format for the CNC machines. Now, long question, but
Yeah, actually, we deliver BIM courses, and we work very closely with CADline in the UK, and the different aspects of it. But BIM here, it needs to be taken up to full capacity. There's huge, we see huge pluses to it, has been taken up in different countries. But coming back to the question, module homes is probably the most exciting thing that BIM can be used as, because it is about the connections and the interlinking and of the different trades, and it's about that being brought along to a maintenance model as well. As a CNC machine interlinking to it, I can't see the problem in that now, and correct me if I'm wrong, but we can connect you directly with our team that's delivering BIM as well.
Very good. Thank you very much. Fascinating, JJ, and hopefully we'll hear more from Future Cast and Construction 4.0 in 23, as Cita hopefully will work closer with you on looking at what the future will bring for construction. Thank you so much.
I think it's a good opportunity for both.
Yeah, thank you very much. So we're going to move on now to our second speaker and our speakers from our great supporters, Arab, who've been with us on our shoulder for this series for 22. So Nicholas and Simon, you're very welcome.
Hi, Ellen. Hi,
so
everyone.
If you'd like to share your screen
here.
and commence your presentation, here you're looking at the parametric design for building structures, a method to provide more efficient structures.
That's correct. Right. So first off, thank you everyone for joining. Very quick introduction. My name is Nicholas Said, and today I'm joined also by Simon Cleflin, and we are both structural engineers at Arab here in the Dublin office. And today we'll be talking about parametric design in relation to building structures. So in this presentation, in the first part, I will be aiming to answer three questions. First off, what is parametric design? Why do we use it? And also, how do we use it in our day-to-day job? And then the second part of the presentation, Simon will be talking about how we use automation to refine our workflows and work more efficiently. So the first question, what is parametric design? Parametric design is picking up pace in the construction industry nowadays. So parametric design uses the power of computation and algorithms to develop interrelationships between key performance indicators. Now that is a bit of a mouthful. So in simplistic terms, parametric design requires inputs. There's an operation which is represented over here with the arrows, and the output would be the key performance indicator. And we often abbreviate this as a KPI. Now, as you can see over here, the arrow is pointing both ways. And the reason for this is that it is an iterative process. So we input the parameters, we get an output, we communicate with the client, and it's a back and forth discussion to find the optimal solution. So over here, we can see on the screen that the input parameters are the building dimensions. And one example of parametric design would be a massing study, which could be carried out in the early stages of the project. And as you vary these input parameters, it will have an effect on obviously the building geometry. So we can see over here that as you tweak the building shape, it will have an effect on the daylight, on the sun exposure. But some other factors that aren't shown on the screen are also the structure inputs. So the building stiffness will also change depending on these parameters. Now that was parametric design on a micro level. However, we can take it to the next level, which would be the macro level, and how it would affect the neighborhood. Naturally, as you change the building shape, it could also have an effect on the wind. So it could either have it could create turbulence behind the building and the surroundings. So this is something that needs to be considered. It's not just the building in isolation, it's everything in the surroundings. And moving on to a larger scale, we also have an effect on the planet. So Arab have committed to calculate embodied carbon emissions for all our projects. And parametric design is an incredibly useful tool for this, as we can find the most efficient solution. And by developing a script which keeps track of all the materials and all the sizes of the members we are inputting, we can also get a figure for the embodied carbon related to our project. And we would obviously have limits for each of these projects, so we can tweak these parameters to make sure we are within these limits. So that was the first question. The next question is, why do we use parametric design? So over here on the screen, we can see a graph which is frequently used. So we have two axes. On the left-hand side, we have the effort, and on the bottom axis, we have time. And there's the different stages of the project, ranging from the concept stage, so we're developing ideas, all the way to the tender stage. And this graph is showing that perhaps effort can also be correlated with implications of change. So it is easier to make changes early on in the project with little cost implications. However, as the project proceeds to the final stages, there's more cost implications. It's harder to make design changes. So where does parametric design come into this? So we start developing parametric design in the early stages, and that's when we can get the most value from it. So right when we have a discussion with the client to develop what are the KPIs, so what will be assessing the building for, we start working our way on the parametric design, and this will naturally involve effort in the early stages. However, you reap the rewards of this towards the final stage where you can assess a large number of changes through parametric automation. So essentially, you're extending the design exploration period, whereas in a traditional method, you would assess a certain number of changes or options. With parametric design, you can assess hundreds, if not thousands, in a shorter period of time. And what happens is that this S-curve essentially becomes a flatter curve. So we are making the process more efficient and there's less cost implications towards the end as you can assess more changes. So the third question is, how do we use parametric design? So we have a workflow here on the screen, and it starts from the left-hand side with the client. So we are commissioned by the client, and we have a discussion with the client to develop the ambitions, also known as the KPIs. So it starts from that step, and the next step would be defining the logic. So an example over here on the screen is a screenshot from Grasshopper, which is one of the tools we use to develop this parametric script. It is used in tandem with a program called Rhino. And for whoever is not aware with this program, essentially each rectangle on the script is an operation, and all the spaghetti lines are linking the operations to another. So essentially, it's an interrelationship between the different processes. And on the left-hand side, you normally have variables where you can move around the inputs, and towards the right-hand part of the script, you get the outputs, which change in real time. But perhaps the best way to show this is with an example. So we recently used parametric design for a project we are the structural engineers on, which is a project in Tirana in Albania. And it's a mixed use development, which is just short of 100 meters. And a few of the variables we used for the parametric design of this building were related to the column sizes, the member sizes, and as you can see, there's two towers that form the geometry of this building. So another variable was the orientation of these towers as we twist them in relation to the other. What effect would it have on the wind? What effect would it have on the views from the apartment, and so on? So there's quite a few variables that were input in this script. And that brings me to the next part of the workflow, which is the analysis. Once we have set up all the geometry of the script, the next part is to actually analyze the script and get the outputs. So over here, we can see two animated images, and they are actually from the project I showed you previously. So we are assessing the deflection of the two towers relative to one another. So in the top image, you can see that we are rotating one tower relative to the other. And as a result, the wind imposed on one building will change. And as you go higher, naturally, the deflections will increase. And on the second image, on the bottom part, we can see that the grid is changing. This will have an impact on the building stiffness, which also has an effect on the deflection. However, besides the structure implications of these, there's also things which will affect the client, such as how much of the floor space is taken by the structure. Naturally, you'd want the more space to be usable rather than to be taken by the columns. And another KPI would be the embodied carbon. The more material using and the more embodied carbon you have related to the project. So how can we optimize the structure to be the most efficient, but also delivering the best results? And this brings me to the final part of the workflow, which is where we assess the options. So with parameter design, like I said, you would have hundreds of options, which could be good solutions. However, you need to select a few of them and also present them to a client to have a discussion on which is the best solution. So for this part of the workflow, Arup have developed their own in-house tool, which we can see over here on the screen. So it's cloud-based storage, and essentially you have the variables on the left-hand side, which you can see the pointer moving the variables around. And as a result, you can see the project changing in real time, and it's an interactive interface. And we found this tool to be very user-friendly, and we received positive feedback from clients because it really helps the discussion to have something on the screen whilst you're presenting to the client, and the client is able to play around with the variables themselves and see what are the outputs. And that is the end of my presentation, so I'll pass you on to Simon.
Great, thanks Nick for that intro to parametric design.
Thank you.
So what you've just seen is just one part of our more global strategy of automated workflows. So that a cornerstone of this approach is really to review our workflows to identify opportunities for automation, and the goal to reduce the amount of manual work and spend more time on actually high value decisions. So optioneering, value engineering, things that, for example, the workflow, the parametric workflow that Nick just presented is what we want to spend time on, as opposed to, say, moving information from one place to another manually. And that also ensures consistency across our design iterations, so that we are always doing the things in the same manner. So in order to achieve this, so first of all, as I said, we need to review our workflow and identify the opportunities, but then we need to implement a way to standardize these workflows, and also we need to have each pieces of this workflow communicate together. So they need to be interoperable. However, in many of our processes, we use, say, commercial software packages that may not be able to be integrated within a workflow. Say they are a black box. You need to input data in them manually, and you get an output that you cannot actually pass on to the next block of our workflow. Other calculations that we do use spreadsheets, and I'm pretty sure you've come across these very difficult to read formulas that you can see there on at the bottom of the screen. They're very difficult to review if you're not familiar with them. So we're losing quality on that. We're losing time of other people trying to understand what's happening in our spreadsheet. We lose trust because anyone can modify the spreadsheet, and we may get lost in revisions and so on. So we're trying really to tackle these key issues at Arup, and one of our approach is to actually develop our own in-house calculations, so that we've called design check. So essentially what we're doing is we are creating those calculations that we need to integrate in the workflows, and we're creating them ourselves, so that allow us to really control the way we get reports, calculation reports out of them. That allows us to spread them globally within all the different offices that say use a similar code. They're very easy to follow. They're line by line calculations with graphs, and they're very standardized, so anyone can review this very easily. And the advantage as well is that we can connect them in our workflows in many different ways. We can go and fetch some calculations from Dynamo. We can go use that in Grasshopper. We have a browser solution for quick calcs. We can call these calculations into Excel, and really always have that consistent, clear output. And that really solves a key issue in trying to put workflows together, is that we can always have like a flow of information from one to another. So an example we've used that on is presented here. So it's an office refurbishment in Dublin. So it's an existing building, and what we're doing is adding 2 stories on top of that existing 6-story office building. So what we really wanted to do here is to assess the reinforcement that was needed for the existing structure to take on the additional loads. And we wanted to have a really granular view of what that needed to be to both save cost and time. And in that way, as opposed to approaching, a building design in a more, engineering judgment point of view, we really wanted to have a clear view of all the existing columns and how they were handling the new loads. So we've created an integrated workflow that starts with a structural analysis model. So we use GSA, that's our in-house software. We built a structural analysis model with it. We analyze it, we get loads, and then we use, say, Grasshopper to create a link between those results and our calculations in Design Check. So you have a seamless transfer of information between the structural analysis model through Grasshopper and onto Design Check, which generates dozens upon dozens of calculations very quickly. And say if there's anything you want to review in more depth, you can always generate reports for each of these individual calculations. So you have just a quick example here. You'll see how your section's looking like. You'll see your moment diagrams, and all you need to know really. And then we're plugging that in onto a PDF deliverable. So we're also plotting the results directly into GA plans. And that really allowed us to eliminate all these these manual tasks, between all of these steps. So all these red arrows that we would usually do by hand. So take forces from GSA, put them in a structural analysis, a structural design software to design columns, and then take those results manually, put them on a plan. All of this, we're doing that automatically, and that allows us to actually save time, to actually interrogate our results more. So say we perhaps there's something we didn't notice at first, but we get odd results on a column that we wouldn't perhaps not looked at otherwise. We get more time doing this and taking the right decisions for our clients and ultimately our design. So I think that's about it for the overview of how we use automation as structural engineers and how we integrate them in our everyday workflows. And yeah, thank you very much for listening.
Thank you so much. I've actually got a Simon and a Nicholas at home as well, actually. So it's a matter of interest. I have 2 boys, Simon and Nicholas, so that's interesting.
Very good.
So much to learn from that process you've just gone through. I just put a comment in the chat there about my profession, or our profession, that is quantity surveying, and why we still have to, be so preoccupied with quantification when we've actually got tools like Grasshopper that can actually work some of this out for us. My question to you both, it was fascinating. I can see the logic here of automation design, addressing, locating, I suppose, optimal solutions. Could it be that the machines will actually, or the algorithmic processes would actually select a better design option than a human would?
That's a very good point, Alan. I think there's an important point to highlight, though, that there's always engineering judgment that comes into this. It's not just the computer that does all the work. So say it's one person that develops the parametric script, there's always peer reviews. So we would select someone who has proficient knowledge in these programs to actually check these scripts. And it's also a cross comparison. So we'd have more in-depth computer models or even hand calculations that we would check. So I think we mustn't forget that there's the human aspect to it. That's where the engineering judgment comes in.
Yes, and I suppose but when one talks about artificial intelligence, you know, that and machine learning, for example, that we could be moving towards a situation where the algorithms will decide on the best option. So we could have a situation where you have automated design in the future, but it makes such sense to, as you said, Simon, to reduce manual work, to focus on higher value decisions, yeah? And to try and automate as much as possible the workflow. My comment there was from our profession in quantity surveying that surely in 2022, we must have the technology that can extract the quantities in line with standard methods of measurement and so on more efficiently. So therefore we can focus on more high value work, particularly in light of the fact that there's less surveyors around and less engineers around. So really, really interesting. Do we have, maybe we have a comment there coming in. Oh yes, on that Mary couldn't agree more, Mary Flynn. Thank you, Mary. So thanks very much, guys. To what extent, Simon and Nicholas, have you saved time? Can I ask that question? To what extent have you saved time in the design workflow?
Well, it really
depends on the building,
how
I suppose. Yeah.
Obviously, yes, and how you approach, how you would approach your design as well if you had to do it manually. But say, for example, if you have to check 90 columns in a building, something like that, you would take probably half an hour doing things manually, just transferring information across, and you might be very prone to error. You might want to speed up because it's a repeat task and sort of leave that.
Yeah.
But
and my
with
last
that,
question to you, sorry for cutting across you there, Simon. Do the graduates today have the skills that you're talking about? Are they coming into your offices with these skills?
It really depends on how they built their education. I'm not entirely familiar with what courses are done, say in Ireland, but more and more we see people who have done more and more people who have done parametric design during their education or programming, and whether they have done it extensively or not, I feel like there's a strong interest, especially from our younger graduates, to get involved in that, and it's and we also facilitate their learning when they join us, and so yeah, there's definitely a huge interest and a great.
Thank you. Well, thank you, Nicholas, and thank you, Simon, for that insight. That was fascinating, and we thank Arab for their continued support for this series. So just encourage all the audience maybe to maybe pop some questions into the chat so we can get some more communications going there. So we're moving on to our final speaker now. Matthew, you've been very patient there. Matthew Bester from Leica Geosystems. Of course, these are companies that are producing state-of-the-art technologies. And if anyone knows anything about autonomy and reality capture, it's probably you, Matthew. So I'm going to hand over to you, and you can.
There we go. Okay, well, I hope you guys can hear me okay. Thank you very much, Alan. I appreciate it.
You were loud and clear.
Thank you very much. It's been a very interesting session so far. So thank you very much. Very welcome. My name is Matthew, and let me take you through a couple of things we're going to talk about today. I'm going to talk mostly about Leica BLK autonomy and its vision. I'm going to introduce you to the fleet, talk about myself a little bit. Also looking at the BLK autonomy overview, what is in the hardware, the software, and the mission planning. We're looking at some of our integration partners that are speaking to these robotic modules that we've brought out, and then looking at some case studies within construction and how they actually use these modules to take people out of risky situations, reduce their staff requirement, and gathering data to make more valuable decisions based on the data that they gather. So BLK, the Leica BLK autonomy vision is basically to make reality capture fully autonomous. So that is everything from data acquisition to processing, and then creating deliverables, insights, and experiences based on the data that we actually gather. So looking at BLK autonomy specifically, BLK autonomy is robots and platforms that require no human intervention. It basically focuses on our Grand Slam technology. I'll touch on that a little bit later, and real-time laser scanning, and then artificial intelligence and machine learning enable data processing. And then autonomy is how these robots and sensors and platforms work together to create a homogeneous autonomous system for reality capture. So looking at BLK autonomy specifically, we've got 3 products in that range, ranging from the handheld system, which is a BLK to go, which is the rise of the Grand Slam, and I'll touch on that Grand Slam very shortly. BLK to fly, which is the world's first autonomous flying laser scanner. And then the BLK ARC. ARC stands for Autonomous Reality Capture. This is a robotics module that we've integrated into various platforms, which you'll see later, but as a start into Boston Dynamics, because it's quite commercially adopted into industry. So a little bit about me. I'm Matthew Bester. I've got 8 years working with SLAM-based systems. I focus on business development in autonomy in the UK, Ireland space, and I'm based in Nottingham in the UK. So looking at these systems, they all generate their own Wi-Fi. This allows us to connect to them with a bespoke app, and that app will then control and give feedback on those systems. So the BLK to go, for instance, which is a handheld unit, we can walk around an environment completely with the system in our hand, and that at the same time, while you're walking, generates a 3D point cloud, as well as capturing 270-degree panoramics every single second. The same thing for the BLK to fly, autonomous system. If you're looking at the control feature there from an iPad perspective, you only select on the facade or the rooftop with your finger where you want this to scan. It autonomously creates a flight path and autonomously actually executes that, capturing the data. You can then fill in the data by just tapping on certain areas that you might have missed. And then also the robotics module, the BLK ARC, also being used with a user interface that's iPad-based. So if your robot is connected to a 5G network, for instance, on the construction site, you can control this robot from anywhere in the world via this interface. So all of these interfaces actually link up to the cloud. So once they've captured data, they've got the ability to upload immediately into the cloud, process the data, mesh the data, make it available for collaboration. So that is quite a nice feature which we've built into these. So I've talked a little bit about Grand Slam. So let me delve into that a little bit more. The ability or the technology that allows these systems to become mobile, move around an environment without the need of a tripod, is called SLAM. So that's simultaneous localization and mapping. It's a robotics algorithm that gives this instrument awareness, if you'd like, of the environment. So using an IMU, an inertia measurement unit, and the laser measurements, all working together with this algorithm and some AI and machine learning, it will actually start generating a 3D point cloud on the move. Excuse me. With the camera system that we have on board and all of these systems, we actually use the cameras as well that are taking photos every single second to look at edges, corners, planes, color variations, to actually triangulate the system and strengthen that odometry, if you'd like. So this system can now move through any environment and capture a 3D point cloud very accurately up to 25 meters as you move, 420,000 points per second, and then also capture the relevant pictures with that we stitch together to give you panoramics. So the LiDAR SLAM plus the visual SLAM and the IMU that we have in all these units generate for what we call the Grand Slam, which is industry first, using both of these SLAM technologies together. In both of these, all of these systems, there's a 12 megapixel high resolution camera that can actually take pictures anywhere along the route. And that is actually anchored within that 3D space. So if you're doing certain quantity surveying, you want to understand how many fire hydrants are there in a floor level, taking a picture with each of these units will actually locate those pictures in that 3D space, and you'll be able to tabulate them in the report that's generated. So the main thing I want to focus on today is the BLK ARC, which is the autonomy reality capture system, talking about robotics. It's got exactly the same features as the other systems, the 420,000 points per second, IMU, SLAM, Grand SLAM system. It's autonomous, it's safe, but not just being safe, it also makes sure that the people on the construction site or the plants or wherever it's used is also safe. So removing people from risky environments. That's one of the main reasons we've built these units to enable data capture in areas where humans can't go. So it's also got the 3 panoramic systems or cameras for the visual SLAM and the high resolution camera in the front. It has the dual axis LiDAR, which is a bespoke LiDAR created by Leica Geosystems that allows you to capture the environment as you move along. These systems are integrated, so we generate what we call colorized point clouds. So that gives you additional visual context when you view these 3D models. We are making sure that it's well protected, making sure that it's got some roll bars, if you'd like. And it all fits into a very nice backpack. That's excluding the dog, I must add. So the system fits into a nice backpack. So once again, this is a robotics module. It can fit into any type of system. The system allows us to do mobile and static scans, so scanning while you walk, but also having static scans at specific areas to increase the density and increase the visualization of that area. So if there's a specific area you want to monitor for how the actual construction progress has been done, or deviation analysis, you can actually stop and gather more data there. Once again, it's all controlled via a very usable, user-friendly user interface on an iPad. So anything that can connect to a browser is where you can actually connect this user interface to. How we do that is we create offline missions. So these offline missions allow the Boston Dynamic dog to actually move through the environment with its onboard collision avoidance systems, but actually follow the instructions that we've given it through the BLK ARC system. And we do that on various ways. We can either take a 2D floor plan of an environment and create polygons with waypoints, or we can use a 3D building plan or a BIM model that you might have of that specific area and create waypoints for the system that way. Or if you have a point cloud that's been captured by any other system, we can also generate those specific missions, as we call them, for the robotic unit to go through. How we orientate that is by generating the use of a fiducial marker, which is a Boston Dynamics standard, fiducial marker 200. That once the dog sees that the mission is loaded, it will actually start following that mission, using its onboard sensors to navigate around any type of obstacles. If it's blocked, it will try and navigate around that to the next waypoint and complete the mission, all the time capturing 3D data for you. So in this specific instance, on the right-hand side, the dog is actually starting to, or the BLK ARC is actually capturing data. It's following a mission. On the left-hand side is where we've actually planned that specific mission, or not this one, but a mission. And you will see that autonomous data capture happening in that area that has been planned. So walking around the buckets and these types of things. On the right-hand side, that stiff leg approach is called the tripod mode. That is a high density scan that's being done at the moment of that environment. So there's more data being captured to have better measurements and comparison. So once the data has been captured, that point cloud is basically then ingested back into the software, and that can be downloaded via the Wi-Fi. So you don't need to actually go and plug it in. If you're sitting in Sydney, Australia, and this is happening in Los Angeles, you can download the data. And you can then start doing scan to BIM analysis. So progress monitoring, deviation analysis, clash detection, whatever you want to do with regards to that specific data set that you've captured. And you could also then, export that in BCF file formats to share with other cloud people. So we want to keep that sharing quite open on the cloud platforms. Another platform that we have called the Animal from Anibotics uses a show and go system. So walking the robot in the area, it remembers the area, and from there on, it can actually execute that mission autonomously. The robot can then also use a CAD model or bin model where you can place that polygon or the waypoints or breadcrumbs for this quadruped, and that will then basically follow that specific route. So that is another way that you can actually do off-site or offline planning of the actual missions. So once you've done that, the platform can then walk around the facility, up, downstairs, and then capture the data at the areas that you wanted. So repetitive tasks, are these columns in the right place? Are they in place? Has MEP been installed? Whichever it may be, that's uploaded automatically to the user, ready for collaboration. And the data can then be used. As you can see, that's a colorized point cloud from the BLK ARC in a plant environment, and that's then automatically ready to share. So we've got various software workflows. Normally, it's the Cyclone Register 360, which people would be familiar with in the Leica Geosystem space. But there's also collaboration, meshing, and modeling software that follows that. So normally, you'll do your mission planning, you'll do the data collection through the means of the autonomous mission. And then there are two work streams. So first one would be desktop-based. If you're looking not to have the data leave site, for instance, and do immediate data analysis, you can follow the normal desktop version. That will basically be dragging and dropping the BTG file, which is generated by the BLK ARC, into Cyclone. That's automatically processed. From there, you can push it over to Cyclone 3DR for data analysis, meshing, comparing it to your IFC models that you currently have of a BIM model, and then doing certain reports and then pushing that back out to the stakeholders. So that's quite a handy feature to have. Once again, we want to make sure that we address all the cloud platforms out there. So BCF, IFC classifications, all of these things are exportable from our software to make sure that collaboration takes place across the platforms that are available. The other workflow that we can look at is HXDR, which is Hexagon's digital reality. This will allow the mission to take place, and through the Wi-Fi, and let's say, for instance, the robotic unit is connected to a 5G network, it uploads those captured files automatically into HXDR, where it's automatically processed, automatically meshed, and then from there, collaboration can happen. You can do basic measurements, you can import certain things, clash detection, and progress monitoring will also be coming into the platform very soon. And then also, you can have certain views. This is data captured with a BLK 360, for instance, an E57 format, which allows you to actually navigate through the environment on the setups that were done. And this is all within HXDR, and you can then navigate the environment for visual inspection or whichever it may be. Some clever filtering. There's normally some noise when people are, if the robot has gone through a construction site that's quite crowded, there might be some data that's picked up, moving people, whichever it may be. So we've got automatic filtering algorithms that look at filtering the data out of this in various ways, either the BLK ARC or BLK to go or BLK to fly, whichever it may be. It clears that out automatically to make data integrity quite high on the list. So we've not just got Boston Dynamics, we've got other integration partners like, for instance, Createch. Createch is a company that is local to Britain. They are focusing specifically on gamma radiation in the nuclear space. So they do sensor fusion by using the BLK ARC from capturing 3D data and then using gamma radiation to overlay that on the 3D space to understand where the radiation is coming from, leaks, hotspots, and the like. So they are quite active in the nuclear space, for instance. We've got a company called Abyss that's using their platform called the Platypus, and that is used for rust inspection and other inspection into docks, offshore oil rigs, and these types of things, looking at what is the status of these installations. It does eliminate a lot of safety issues, and in a lot of these times you will find that we're around about 7 times faster than they would normal tripod or a manual process. So first of all, we eliminate the person out of the risky environment, but we're also much quicker. Then there's a Toomey Robotics. These robots are very well used within the mining space, in the mining industry, for instance. So heavy construction, looking at underground mapping. This is a wheeled robot, for instance. And basically what it does, it will scan the area, upload the data. And this is some of the horizontal linear projects that it can generate. A meshed tunnel, for instance, looking at overbreak, underbreak, for the geological guys to look at rock stability and the like. But also, if you're looking at vertical stuff, be it elevator lifts or manholes or whatever it may be, if you want to understand the structures, that can also then be lowered down these structures to capture data in 3D and understand that better. So anabotics, as I've mentioned, this is one of the other quadrupeds that we've used. Very unique system, as it basically has got the show and go from an autonomy perspective. It captures not just the 3D point cloud that is enabled by the BLK ARC, but also it's got thermal imagery, very high resolution imagery, and it also actually picks up audio. So listening, is the generator running? Is there a specific sound? Some maintenance people would actually have an ear for if the engine is running in the right way. So a lot of applications for this type of unit. It's waterproof, so it can be sprayed. Unfortunately, our system is not, but there's also an XE system that's deployed on oil rigs that is fireproof. That is quite useful as well. And they can visualize and analyze the data in their platform. So a very high precision scanning system that's available with the BLK ARC as well for additional visual inspection in your construction environment. They use the BLK ARC for scanning 3D spaces because it's a bespoke, custom-built LiDAR scanning system. The accuracies are better. You will see a lot of the Velodyne pack deployments in a lot of the systems, which is fine. The default pack will be on these systems because it's made for navigation. It's made for automobile navigation. It serves its purpose in that specific regard. But with the BLK ARC, it's a laser scanning system where you want accuracy. And then once again, a seamless integration into their workflow. One thing with the BLK ARC is that we've got an API available where you can start, stop, pull data from the scanner. So that can be integrated into any other type of platform that can call on APIs. Drone Deploy is another company that uses the BLK ARC for autonomous missions. Also looking at sensor fusion. And when I talk about sensor fusion, I'm talking about additional payloads onto the robotic platform, where they can take, for instance, in this specific instance, a 360 camera, where they will do more 360 panoramics of an area, at the same time capturing 3D data. And that is for automatic inspections. So, are there things that have fallen over? Are there areas that they need to focus on that's not been completed yet according to the site plan? Are there high-risk areas that need to be investigated? So combining these two sensors, they can actually constantly focus on capturing data. As you can see, there's a docking station. So, if you have got these docking stations planted all over the place, you can actually run these autonomous missions quite effectively from a remote site. And once again, they use this for issue identification and classification reporting, as well as remote rectification reports and these types of things. So was the work done or not, and update that from a central operating center. So some of the use cases that I'll quickly go through, we've got Turner Construction, looking at making sure that they give the robotic module a lot of work for routine, mundane stuff. And that is for the VDC teams to check that everything, according to the BIM model is been done, that said it would be done. Places that are ridden with asbestos, old buildings, when you're looking at renovations or decommissioning or demolishing, you would actually send in something that's not a human life. These clients regularly use things like the BLK to go, the handheld system, and as well as the tripod-based system, RTC 360. In Plenia, they also use the BLK ARC on the anabotics animal, and that's looking for full autonomy, looking at scheduled inspection missions, making sure that everything has been installed that said would be installed, and then some other large contractors within the US as well, looking at those autonomous tasks, looking at those monotonous tasks, looking at inspection, taking the person out of the environment, and then getting that data straight away without it having been delayed or having something missed. And Alan, I see you looking at me, so I'll
No, you're okay.
I'm okay.
Yeah, you're okay.
So Pomerlau, another specific customer that has used the BLK system. Immediate value that they started seeing was data capture in places that humans couldn't go. They could remotely monitor the project, which is a great feature, especially when people have left site and you can have an additional workhorse that doesn't strike or need a lunch break. And then field validation against the design model, which is the most common use that we see in this specific technology. One thing that I want to go to, okay, well, General Motors, also a very avid user of Leica. They basically would use the BLK ARC system to go and scan their plant in areas, while other surveyors are looking at high accuracy areas that they need to capture. So, it's horses for courses at the end of the day. If you want to send out the dog and make sure that there's other areas that would take a long time to get to or needs regular inspection, you can actually use BLK ARC for that. This one is quite interesting. I would like to look at where the Hexagon Smart Manufacturing has been introduced. Leica Geosystem is part of Hexagon, the larger Hexagon, and we've got a very large suite of software that look after various things. Certainly computational fluid dynamics, looking at how the building would react while it's still within a specific phase. So looking at these simulations, I don't have that simulation that's playing at the moment. Basically what the simulation would show is, sorry, that's mine.
We need to start wrapping up soon, Matthew.
Yeah, certainly.
Yeah, no problem, yeah.
Is my screen sharing off?
Yes, it is, yeah.
Okay, certainly. Just with this computational flow dynamics, we can actually overlay things that would, implement the cooling mechanisms or the cooling effectiveness of the aircon systems, and that can be done in an AR specific way, looking at the real environment from the design model and see how the cooling would be effective, or the heating, how smoke will dissipate through a building, these types of things. But that's what our technology is used for, all in an autonomous way.
Thanks very much, Matthew. Fascinating. It's always fascinating to see how the tech companies are constantly developing. So I might ask the speakers just to put their cameras on. I know a few people had to leave early, but yes, I mean, SLAM, I actually hadn't heard of it before, but simultaneous localization mapping, which allows robots to explore and understand its environments. Would that capture more or less what we're talking about here? Yeah,
that's correct. So SLAM technology, yeah.
We were actually chatting about this yesterday in the university because we have a new project. We're going to be talking about this project on the 9th of December, I think it is. It's the final event in the series, looking at productivity. But this is the DTIF, the Disruptive Technologies Innovation Fund AI project that TU Dublin were successful with Evercam and Gaga Muller. And while we're not using SLAM technology, we're using time-lapse cameras, sensors. I would have thought that SLAM and BIM and scanners all working together would be a fascinating cocktail of technology, because if we look at construction today, there's a huge need at the moment for the technology companies to fix the compliance problem in construction. You talked about the machine understanding its environment, but the idea that the machine capturing, fire protection going into critical components of the building, the machine ensuring that there's constant data capture so that the clients and the authorities that are building these units are assured that the buildings are built correctly into the standards that are required. This is going to be increasingly important, I think, as we move forward. It's been a fascinating event. I've learned so much. The word autonomy was used an awful lot this afternoon. I suppose if one was to define the term autonomy, it's the idea of being self-governing. The idea that you have, JJ, you mentioned autonomous vehicles. Simon, Nicholas, you mentioned algorithms a number of times, automated design. And I don't know, I think Matthew probably mentioned autonomous and autonomy multiple times. So that's what it's all about. it's about using technology, I guess, to I think was it Simon that talked about, you know, reducing the manual, the rework, focusing on high value decisions, and getting rid of the mundane tasks, particularly at a time when we're struggling to get people, and at a time when all this wonderful technology is around us, we should be using it. So I'm not sure we have time for questions. We just have a quick look at the chat to see if there's anything in there. I know that there was a lot of compliments, by the way, from Robin and Linda and Keith, that you all did a fantastic job. Also, Keith, Daniel Keating was talking about the importance of new graduates, you know, having the skills for scripting and automation design and so on and so forth. Can I just take the opportunity to thank the Cita team, to thank you, JJ and Nicholas and Simon and Matthew for your contributions this afternoon. This is obviously will be recorded, and so we'll be back, as I say, in early December, looking at productivity, the productivity challenge, and how we can create maybe smarter construction sites. We'll also be on the 29th of November, we'll be continuing with our regional event series, and actually soon we'll be announcing our plans for 2023. And I think automation, AI, robotics will definitely feature, and we'll have the BIM gathering next year and so on. So listen, thank you so much. I wish you all well, and you did a great job, guys. And thanks for all the people that came along today.
Thanks for having us.
And
Thanks
continues to.
Thank you for having us.
Thank you.
Thank you very much.
Thank you,
Bye.
guys. Have a good
Bye-bye.
day.
Thank you, Alan. Thanks.